Hi everybody, we are back again. We're going to look at drug calculations. We're going to extend out what we've been doing just a little bit further and look at adding some material to the top of our formula. So we've been looking at this, excuse me, hold on one second. We've been looking at this, and if you recall, it's always doctor's order over dose on hand. So we're going to start with one that we've already are aware of in terms of what we have on hand. And we're going to say that this is 100 milligrams in 5 milliliters. And the doctor is ordering you to give 1 milligram per kilogram. So now we've added a brand new step into this mess. But we're always going to do what we've started with. We always stick with it. We're going to start on the bottom and then work our way up. So the first thing we'll do is we'll start on the bottom. Let's make this, don't panic, we're just going to make this simple like we did before. We're going to divide the bottom into the top. So the 5 goes on the outside of the bracket, and we know 5 goes into 10 2 times, and then we can drop this 0 down, and that means that we're going to add a 0 here. So rewriting the question out, you have 1 milligram per kilogram. That's still the same up top. We haven't done anything with it yet. And now we know that the bottom is 20 milligrams per milliliter. So we've got this where we need it to be, but we've got to do something here. This is very different. So let's take a look at that right now. What you're going to do is you're going to do a separate calculation to figure out what the kilograms are. So it's always 2.2. You're going to divide the pounds by 2.2. The 2.2 is for absolute accuracy. If you're on long-term transports, long interfacility transports, you want to be as accurate as possible. On our short terms, the quick run from the cardiac arrest that we return spontaneous circulation, and you are hanging in infusion of an antiarrhythmic like your lidocaine, you would be able to do this rather quickly, and you could just divide their weight in half, so you could divide it by 2. But for testing purposes and for accuracy in long distance transports, we definitely want to make sure that we do this by 2.2. Now this is the math that gets people screwed up. We'll say that this patient is 130 pounds. So all we've done is we've said, okay, so we've got to figure out what the kilos are. We know that the patient is 130 pounds. We're going to divide that into 2.2. Now people tend to get excited, they move too quickly, they don't take the time to put in their decimal points, they forget to move things over, and that's where we end up giving wrong medication dosing. So we're going to go over that right now. If you have a decimal point, which you did here, you've got to move the decimal point here as well. So that's what we're doing. And I'm going to go ahead and put that 0 in, and I'm going to put a decimal place. That way I don't get lost. So now we know 22 won't go into 13, but 22 will go into 130. We just have to figure out how much. So 22 times, let's try 6. So that's 12. And that's going to be 132. That's not quite right. So we know that it's got to go 5 times. So let's come up here. Let me erase that just so we can clean up our workspace. And we're going to go 22 times 5. And that's going to give us 110. So we're going to place the 5 directly above the 130. And we're going to put 110. And we're going to subtract. So 0 minus 0, 3 minus 1, and we have to bring this 0 down to make it 200. So I can already tell you that when it comes to 22 times what to go into 200, let's make that 9. That's 18, and that's going to be 198. So we've got 59, and we're going to go 198, and we're going to subtract just like we did before. Now we've got a 0, so we've got to take away some things. We're going to move that down. We're going to get rid of things. We're moving them away. So 10 minus 8, 2. 9 minus 9 is 0. So we are good. Now we do have this decimal point here, and you want to work these out at least 2 spaces just so you can make sure that you're not going to have to round the number up. So 22 won't go into 20. So that's obviously going to be a 0 here. We're going to add another 0. We're going to drop it down. We're going to add it on, and we're back to where we were before. So it's 59.09. That 9 would round that 0 up to a 1. But because it's not a 5, anything that's 5 or greater, that's when we would actually up the pound by 1, or the kilo by 1 point. So we would turn, if this was 59.5, then we would just round that up to 60. So that is the goal when you deal with the kilos, is you want to round it to a whole number. So I'm going to pause the video, I'm going to clean this up real quick, and then we're going to talk. Alright, so I've got us cleaned up here, and we're taking a look at this. Now, here's something that's a little counterintuitive for some people because they really get hung up on this fraction or this hash point here. So when a doctor is ordering you to give 1 milligram per kilo, what he is saying is that for each kilogram of body weight, which we know is a total of 59 kilos for this patient, then you're going to give 1 milligram of medication. So for every kilo of body weight, we're giving 1 milligram. This one is really simple. It's 59, and we always multiply it so by the amount of medication we're given. So we know that the top is now going to be written out a little differently, and I'm going to shift down here so you can see it. 59 milligrams is your doctor's order, and your dose on hand is 20 milligrams per ml. So now it looks something a little bit more familiar of what we've been working with. So we'll do our typical steps. We're going to remove what we have in common. We're going to take the bottom and we're going to put it on the outside of the division bracket. Put the 59 on the inside. We're going to go ahead and place our decimal point. So 20 will go into 59 how many times? It won't go into 5 times. It won't go into 4. It won't go into 3, but it will go into 2. If you took 20, let's come over here, 20, and you multiplied it by 3, you're going to come up with an answer of 60. So that's 1 too many, but we can do it at 2, and we're going to come up with 40. So we're going to subtract. 9 minus 0 equals 9. We're going to go ahead and drop that 0 down because we know we're going to need to. And then 5 minus 4 is 1. So 190. So now we look at 20 and we go, well, let's see. If we do it 9, if we multiply that by 9, then that means that we have 180. So that sounds pretty good. So we're going to put a 9 here. We're going to put that 180. And we're going to subtract it. And that's going to give us 1 and 0. And then we can actually drop down the 0 and get 100. 20 will go into 100 5 times. So your answer here is 2.95 milliliters. That's how easy it is. All we're doing is adding in the kilograms. We just have to figure out what the kilo is. And remember, we always do that by dividing by 2.2, so we've got to remember that. But if you can do this, you'll be good to go. I'm going to give you a one practice session here, and then we're going to move on. Okay, we're back. Here's your practice one. It is 0.01 milligrams per kilo. Of course, we're dealing with a 40-pound child, so children are going to be in kilo-based more than probably anything else that you're going to encounter. And what our dose on hand is currently 10 milligrams per 10 ml. So this is all very, very simple on the bottom. So we're trying to make this as simple as possible. But if you would like, please pause the video now and come back into it after you've practiced yours, and let's see if you have the same answer I've got. Alright, so we've taken a break. I've worked this out, and hopefully you have too. I'll walk you through the steps for what I did. So the bottom was very simple. All we had to do was get rid of the 2 zeros that each of that had in common. So that left us with 1 milligram per ml, which I've rewritten down here. The other thing that I did was I took the 40 pounds and I divided it by the 2.2. So again, we've got to make sure that we move that decimal point, and we do that here as well. People really mess up when they move through this part too quickly on the test. They think they can do the math in their head. It's really not a good idea to do your math in the head, because you have a tendency to misplace those decimal points or to leave them out. And that's my dog eating in the background, so I apologize. Apparently it's time for dinner. So 22 will go into 40 one time. So 40 minus 22 is going to equal 18. We're going to drop the 0, and then we're going to say 22 can go into 188 times, and that gives us 176. So you're going to subtract that, you're going to make that into a 10, we're going to take away 1 from here, and we're going to drop that, subtract, and that's minus 40, or excuse me, minus, and you end up with a 4, and we're going to drop the 0, and we're going to see that again, this is going to be a repeating number of 1818181818. It's just going to keep going. So this is not enough to increase this number to pop that one, so we're going to leave our kilograms are going to be 118, or we're going to leave our kilograms at 18 kilos. So for each and every kilo of body weight, for 1 kilo of body weight, we're going to give 0.01 milligrams of a medication. So we've got to take the 18 and we have to multiply it by the 0.01. And you can see I've worked this out here. 8 times 1 is 8. 8 is 0. 8 is also 0. 1 times 1 is 1, 0, and then our last one, which would be 0. And we're going to bring all this down, and you're going to see the 2 decimal points. We're going to move it over 1, 2, and that means that we're going to give our answer, what you should have came up with was 0.18 milliliters, because these are the same. If you don't understand what I'm saying, you got 0.18 up here. We're going to finish this out by doing our divide the bottom into the top, which we really don't need to because it's over 1, but if you wanted to, this is how it would look. So either way, your answer is going to be 0.18. And if you have any questions or need any further explanation, please feel free to give me a shout in class, and we'll give it a go, and we'll work on it together.